Okay, today we're going to be looking at half angles and double angles. I don't know if you can see the double angle in there, that we have two angles right here. So we have our half angles and our double angles. All right, so our goal for today is basically there's two formulas. There's a half angle formula and a double angle formula, and our goal is to know them and use them. Now they're on our blue sheet, and there's half angles, and you're going to notice there's a bunch of different half angle and double angle formulas, especially for cosine. So with sine, it's pretty basic. That when we say the sine of 2 times an angle, it's always 2 times the sine of that angle times the cosine of that angle. But when we're talking about cosine here, you have some choices, and it's kind of depending on what you want to do. You can say it's cosine squared minus sine squared. You can say 2 times the cosine squared of that angle, or 1 minus 2. It kind of depends on which one you want to use. I'd say a lot of the times I'm going to use the top line here, but I want you to know that you have options, and it's just important to know that you could use all of them. I'd say most of the time we're going to use the top. Tangent of 2 times an angle is just 2 times the tangent of that angle, and then 1 minus the tangent squared of that angle. All right, just like in the sum and the difference, it really just helps to do some of these. So let's go ahead and do that. Let's go do a few of these. Oh, I guess I'm gonna have to pull these down here. Anyway, so we're looking at, first of all, the sine of 2 theta, and I'm gonna go so I can kind of see my formula up here at the same time. Sine of 2 theta. So my formula is that it always equals 2 times the sine of theta, all right, and cosine of theta. I guess I've jumped the gun here a little bit, and I apologize for that. We had sine of theta is 3/4. So what I needed to do first is I needed to just draw my triangle here, where the sine of the angle that I'm talking about, the sine is 3, and then the hypotenuse is 4. That would mean that our missing side here would be 16 minus 9, the square root of 5. That's our missing side. So we're always looking at this triangle, this reference angle, when we're going to kind of answer our questions here. So our answer here is 2 times whatever we get for the sine of that angle. Well, the sine we already know is 3/4, and then times the cosine of that angle, square root of 5 over 4. So our answer here is 2 times, excuse me, I made a mistake here, 2 times 3 times the square root of 5 on the numerator, and my denominator would be 4 times 4. So our answer here is 6 times the square root of 5 over 16. If we reduced it down, it'd be 3 times the square root of 5 over 8. That is our final answer, okay? So it's a lot about using your formula, kind of plugging in our values into our formula. Now let's look at our cosine. All right, cosine. The formula is cosine of 2 theta. Let's go with cosine squared minus of theta, and then minus sine squared. Let's go with that. Okay, cosine squared. Cosine would be square root of 5 over 4, and we have to square it. And then we're going to subtract sine squared, so minus sine squared. Sine would be 3 over 4, and we're squaring it. So let's do that step. Let's go ahead and square it. All right, so I'm going to get more space here. Thank you. Way too much space, sorry. All right, so square root of 5 squared is 5. Denominator 4 squared is 16. Minus 3 squared is 9. 4 squared is 16. Our answer is negative 4 over 16. Reducing that fraction, it's negative 1/4. That's our answer to the cosine of 2 theta. So this is kind of when they give us a theta and how we would find the cosine of 2 of those angles. And we have another example here too. So now let's look at this tangent. So the tangent here of 2 theta, if you can look at your formula, it's 2 times the tangent of theta divided by 1 minus the tangent squared of theta. And I did miss a theta on that, all right? So when I look at this, all right, I have to go back to my formula here to say, okay, my tangent is 3 over 5. So we have 2 times 3 over square root of 5. I said it wrong even, all right? And then it's over 1 minus, and then 3 over square root of 5 squared. So 2 times 3 over square root of 5 would be 6 over square root of 5. And then my denominator would be 1 minus 9/5. Honestly, go ahead and circle it and call it a good day. I could be like, oh, let's figure this out. Let's see what this is. This would be like, because if this was like 5/5, this would be -4/5, and so we'd have a denominator of -4/5. Numerator would be 6 over square root of 5. We can flip and multiply. 6 over square root of 5, and then we have 5 over 4. And then it really doesn't help us that much. It turns out to be 30 over 4 square root of 5. Again, circle it and call it good. All right. Now, let's see what happens when we look at the next type, which is half angles. All right. Now, we talked about these double angles. Now, I showed you double angles where they gave us an angle. You could have also done double angles where they said, okay, what is the cosine? I got to think of a cool one. 90, all right, the cosine of 90. Well, you could say, really, that's the cosine of 2 times 45 degrees, all right? And so you can apply this same formula, and then we could figure out, well, that's how I could prove I know what the cosine of 90 is. Well, we already know the cosine of 90. It doesn't really work unless we're in the 30, 60, 90 types of triangles that we have, because 2 times the 30 degree is 60 degrees. Hey, we already know how to find that. 2 times the 45 is 90 degrees. We already know how to find that. 2 times the 60 is 120. We already know how to find that. So we don't use it too much in this context. We use it more in this context where, okay, I'm thinking of a triangle like this. And so the sine of this triangle is this value here. So this is more the type of question. In this type of question here, where we have half angles, and I've got to make a note here, is that we're looking here for half angle formulas. We're on the note sheet that I gave you, I have this wrong. Please change it. Right here, it should be plus in the denominator. I have a minus in the numerator and the denominator on the note sheet. So please fix your note sheet. My blue note sheets I gave out. Oh, I'm so sorry. I apologize greatly that I have a mistake there. It was just a typographical error. This is correct, okay? Again, this is a lot about we have a formula and we're going to use our formula. So let's start with this one. Cosine of pi over 8. Well, first thing I'm going to do is I'm going to multiply it here. And we have that equal to the cosine of 22.5. Wow, 22.5. Oh my goodness. And you think, well, how am I going to find 20? There's no way I can add, da, da, da. Well, what you realize here, hopefully, somewhat quickly, is that is actually the cosine of 45 divided by 2. 45 divided by 2 is 22.5. Huh, I can use this cosine half angle formula there. So the half angle says when I have the degrees that I know and I have it divided by 2, I can follow this formula to find out the answer. All right, kind of slick now. So what I do, and I always just have this plus minus means there's like a positive value and a negative value for the 45 or for the angle right here. So I'm going to say here 1 plus the cosine of this 45 degrees, the reference angle that we're dealing with, divided by 2. So all you do here, it's really just about writing your formula. What we have you do is we just have you write down cosine of 45 degrees is square root of 2 over 2, and then this is all over 2. Again, I could be mean. I'm just not a mean person to say, okay, reduce this, make it all look pretty. Go ahead and leave it like that. And that's how we're going to leave it. It's more that I want you to get familiar with the formulas and that you know there is a formula, that a formula exists. And that's what I'm more happy with. So let's look here now. My next problem is the tangent of 15 degrees. I could make this into an addition problem. Don't get me wrong, or actually subtraction problem. I could say tangent of 15 degrees is really tangent of 45 degrees minus tangent of 30 degrees. It would work. We would get the right answer. But I'm giving you another option. I could also say this is the tangent of 30 degrees divided by 2. All right, and then with the tangent, I know that that is equal to 1 minus the cosine of that 30 degrees and 1 plus the cosine of that 30 degrees. Oh, okay. Well, plus or minus, and actually we leave the plus minus in there. And 1 minus cosine of 30. Cosine of 30 is square root of 3 over 2. 1 minus square root of 3 over 2. I need more space here. Sorry, gotta go. And then divided by 1 plus square root of 3 over 2. All right, and it's the square root. We just leave it like this. We call it good. We leave it like that and call it good. Okay? Don't worry about simplifying. We can just leave it like that. Our last problem, cosine of 105. Well, you know that we're dealing with half angles. So what I'm going to say in my head is I'm going to kind of go off to the side and go, what is 105 times 2? I'm just wondering. Here we go. 2 times 5 is 10, 2, 3, 2, 230. Oh, I can figure out 230. That's on my, no, it's not on my list. What did I do wrong? 10, 2, 3, 2, 230. Huh. What did I do? Oh, that doesn't work. The double in it doesn't work. How about if it's a double angle? Cosine of 105. Let's go 105 divided by 2. 52.5. That doesn't work. Oh, it's 210. That's what I did wrong. 210. All right, so it is the cosine of 210. You know, if I was good, I would be able to cut these up and make it look nice when I do a recording. I don't know how to do that, so apparently we're not going to do it. We'll leave the mistakes. It makes it interesting. Cosine. The cosine formula here is plus or minus the square root of 1 plus the cosine of the reference angle that we were dealing with, in this case 210, all over 2. So our answer, we're just going to write 1 plus, we have to look up on our sheet, whereas 210, the cosine would be negative square root of 3 over 2, all over 2. Call it good. That's it. We're going to call it good and be done with it with that. Assignment for this, what I want you to work on, I want you to go through 14 through 17 and then 21 through 25. And these are just good overall problems to work out and use your half angle formulas. It's really about applying the formulas. Good luck.